Okay, still on differentiation, and we are looking at rule 1. Now, what's rule 1 say? Now, rule 1 is saying that if you have y equals x raised to the power n, now your dy dx is going to be, the n will come down and you will minus 1 from it. So it's going to be nx n minus 1. That's how to differentiate. So that is, if you have anything up, bring it down and then subtract 1 from it. So meaning that, example, if for example I have y equals x raised to the power 2 and you are asked to differentiate, so of course your answer will be dy dx. dy dx means change in y over change in x. Is going to be what? 2x. You see that? 2 will come down and then you minus 1 from this, because if you say 2 minus 1, 2 minus 1 eventually will give you 1. And in mathematics, when you have x, is automatic, is raised to power 1. You don't need to show the 1. So 2 will come down and then you minus 1. That's the answer. So meaning that if I have y equals x raised to power 4 and I want to differentiate, dy dx is going to be 4x raised to power 4 minus 1, which will now be 4x raised to power 3. So that is, bring down the 4 and minus 1 from it. So 4 minus 1 gave us 3. That's the answer. So if you are asked, differentiate y equals to x raised to power 10. So of course your dy dx is going to be, the 10 will come down, 10 x raised to power 10 minus 1. Then you now have 10 x raised to power 9. That's the answer. Very straightforward. So you always minus 1 from the power. Always. Okay. Now, if the question is this way, so if I have y equals x raised to power minus 6, you see this one? This is a negative power. So your dy dx, is going to be, bring down the minus 6, then minus 1 from the minus 6. So minus 6 minus 1, that will give you minus 7. 6x raised to power minus 7. Minus 6x raised to power. Because minus 6 minus 1 means you are owing 6, you are owing 1. Altogether, you are owing 7. Minus 6 minus 1 is not minus 5. If you are not sure, press this in your calculator. You will see that this is what it will give you. So meaning that if I have y equals x raised to power minus 12, so the dy dx is going to be, bring down the minus 12, x raised to power minus 12 minus 1. And that will be minus 12 x raised to power what? Minus 13. You see that? Because minus 12 minus 1 is minus 13. And that's your answer. Okay? Having said that, still on rule 1, now you can have a question like this. You can have a question like y equals x raised to power 2 over 3. Differentiate. That's a fractional power. So what you do is you say dy dx equals to, bring down the 2 over 3, 2 over 3x, then 2 over 3 minus 1. You see that? So this one will now give you 2 over 3 x raised to power. Now, anytime you are subtracting a fraction from 1, see what you are going to do. Now you will say 2, the up numerator minus the denominator, 2 minus 3. 2 minus 3. 2 minus 3 is minus 1 over 3. Now what I'm saying is this. If I have 4 over 7 minus 1, how do you solve this? Just say 4 minus 7. 4 minus 7 is minus 3 over this 7. That's the answer. If I have 5 over 2 minus 1, for example, I'll just say 5 minus 2, that is 3 over 2. You see that? If I have 8 over 11 minus 1, I'll just say, or 8 over 13 minus 1, I'll just say 8 minus 13 minus 5 over this 13. That's it. So you see that? That's how to subtract a fraction from 1. So you will apply that here. So meaning that if I have y equals x raised to power 4 over 7 differentiates. So my dy dx is going to be 4 over 7. You bring down the 4 over 7. X raised to power 4 over 7 minus 1. And then by the time you do this, it becomes 4 over 7. X raised to power 4 minus 7 is minus 3 over 7. That's the answer. You see that? And lastly, on rule 1. Lastly, on rule 1, if you have a question like this, you have y equals x raised to power minus 6 over 7 differentiates. Minus y equals x raised to power minus 6 over 7 differentiates. So here your dy dx is now going to be the minus 6 over 7, bring it down, minus 6 over 7x, you write the x, then minus 6 over 7 minus 1. So your dy dx is now going to be minus 6 over 7 x raised to power. Now as you have minus 6 over 7, so what you will just say is to say, since it is minus, you will add it. 6 plus 7. 6 plus 7 is 13. So you are going to have minus 13 over 7. You see that? Minus 13 over 7. Because it is minus minus, just add this numerator and denominator over the denominator. So let me do one more example on that. Let's say you have y equals x raised to power minus 5 over 3. Differentiate. Y equals x raised to power minus 5 over 3. Differentiate. So here now, your dy dx will now be, bring down the minus 5 over 3. Minus 5 over 3 x minus 5 over 3 minus 1. So my dy dx is now going to be minus 5 over 3 x raised to power. So you just say, add these two together, 5 plus 3, that's minus 8 over 3. Because of this minus, you will still put it there. So you see that? That is that is rule 1. So when you see any question on rule 1, this is how to differentiate. Okay, quickly, let's move to rule 2. Rule 2. Rule 2. So rule 2. Rule 2 now. Now rule 2 says if you have y equals ax raised to power n, so your dy dx will be equal to n will multiply the a. You have an and x raised to power n minus 1. You see that? So n is multiplying the a, then you minus 1. So examples, let's say you have y equals 4x raised to power 3. So differentiate. Of course, your dy dx here is going to be, we will multiply the power and the coefficient. 3 times 4, that will give you 12. Then you will minus 1 from this 3. 3 minus 1. So that will be 12x squared. That's your final answer. So you will first use the power to multiply the coefficient and then minus 1 from it. Okay, look at if I have y equals 6 x raised to power 3 raised to power 4. So to differentiate, your dy dx is going to be 4 times 6, 24 x raised to power 4 minus 1. And then your final answer will be 24 x raised to power 3. You see that? So you will multiply 4 times 6, 24, minus 1 from the 4. That gives you 3. Okay? Now, if you have y equals 5 x raised to power minus 3. Look at this. How do you differentiate this? So your dy dx here is going to be minus 3 times 5. That will give you minus 15. Then minus 1 from this 3. Minus 3 minus 1. So here I'm going to have minus 15 x raised to power minus 3 minus 1 is minus 4. Minus 4. So that's what you are going to have. You see that? Then, now, look at, still on root 2. Still on root 2. Now, if you have something like this, you have y equals 2x raised to power 4 over 5. Look at this. 2x raised to power 4 over 5. Differentiate. Now, if you want to differentiate something like this, of course, your dy dx is going to be the 2 will multiply 4 over 5. You see that? Then x 4 over 5 minus 1. You will use the fraction to come and multiply the coefficient and then subtract 1 from it. So here now, 2 times 4 is 8. So 8 over 5. X raised to power. Now I've told you when you are subtracting a fraction from 1, just do numerator minus denominator. So 4 minus 5 is minus 1 over this 5. So that's the answer to that. Do you see? Now, if you have, for example, again, y equals 6 x raised to power 5 over 7. Look at this. So your dy dx is going to be 6 times 5 over 7 x raised to power 5 over 7 minus 1. You will bring the fraction to come and multiply this 6. So by the time you multiply that, you are going to have 6 times 5 is 30. So our dy dx will now be equal to 30 over 7. 6 times 5 is 30 over 7. Then x raised to power 5 over 7 minus 1. So 5 minus 7 is minus 2 over 7. That's your answer. You see that? 5 minus 7 is minus 2 over this 7. And lastly, if I have y equals 3 x raised to power minus 4 over 5, differentiate. So my dy dx will now be minus 4 over 5 times 3. So 3 times minus 4 over 5. Then x raised to power minus 4 over 5 minus 1. You will subtract 1. So here now, your dy dx will now be 3 times minus 4 minus 12 over 5 x raised to power minus, because it's minus minus, so 4 plus 5 is 9. So minus 9 over 5 over this denominator. That is your final answer. So this is rule 1 and rule 2. So in my next class, I'll be going to composite function or function of function or chain rule. That composite function is the most fundamental, rule in differentiation. All other principles are hanging on that principle, and so you can't afford to miss that class. So you can click on subscribe button as you are watching and click on the bell button so that when I drop the video for composite rule or function of function, you'll be able to know, and then you watch. Thank you. Good day, everyone. Today we are looking at differentiation, and what we are considering is the composite function. Now, composite function, like I said in the previous class, is the same thing as function of function, or the same thing as chain rule. Now, what is this composite function saying? Anytime you have a question in a bracket, let's say you have ax plus b raised to power n, ax plus b raised to power n. How will you know that a question is composite function? How you will know a question is composite function is when you have a bracket and a power. Once you have a bracket and a power, and then you are asked to differentiate, that is composite function. And of course, the general rule that is that if I want to find the dy dx of this, is going to be an, then ax plus b raised to power n minus 1. Now what this is saying is that I'll differentiate this ax and then bring it out, bring the a out, then use the n to multiply, and then minus 1 from the n. But the composite function or chain rule is saying that dy dx at every given point is always dy du times du dx. dy dx is equal to dy du times du dx. This is composite rule, function of function or chain rule. This rule is so fundamental to differentiation that you have to get it right here, because once you get it right here, when we get to exponential function, logarithmic function, trigonometric function, application to business and economics, we are going to be using it. So at any time you see a question that it is a bracket and one power, then you should know that it is composite function. And the rule is that dy dx is always equal to dy du times du dx. Let's take a question and then apply this formula. Okay, now let's say you have something like this. Let's say given y equals x plus 5 raised to power 6, and they say find the derivative. Find the derivative. Look at this. Now, the moment you see the question that it is a bracket and a power, now what are you expected to do? You already know it is composite function. So the first thing, solution, is to say let u be equal to whatever you have in the bracket, x plus 5. So let always u be equal to what you have in the bracket. So if I have x plus 10 in the bracket, u will be equal to x plus 10. If I have 2x plus 7 in the bracket, u will be equal to 2x plus 7. If I have x minus 15 in the bracket, u will be equal to x minus 15. Whatever you have in the bracket, let u be equal to that thing. Then from there, you will now rewrite this question. So I'm going to have y, this y now, is equal to, you know, you have replaced the whole of this bracket with letter u. So instead of writing this bracket now, you are going to write u raised to power 6. You see that? Now the first thing is to represent the whole of the bracket with letter u. Then rewrite the question, write y, then u raised to power 6. You see that? So from here now, you know I have letter u and letter x here. So from here I will find du dx. du dx. Du dx means I want to differentiate this. If I differentiate x, it will give me 1. Anytime, now I'm going to quickly say some things now which I want you to take notes. Make sure you pause the video and write them down. If I have y and y prime means differentiation. If I'm to differentiate x, it will give me 1. Anytime you are differentiating ordinary letter, it will always give you 1. Differentiate k, 1. Differentiate p, 1. Differentiate y, 1. Differentiate hem, 1. Once you are differentiating a letter, it will give you 1. Now, once you are differentiating a number with a letter, it will give you that number. So differentiate 2x, it will give you 2. So differentiate 10x, 10. Differentiate 50x, 50. Differentiate 50m, 50. Differentiate 92y, 92. Differentiate 73k, 73. Anytime you have a number and a letter and you want to differentiate, it is going to give you that number. Then anytime you are differentiating a constant, let's say like 10, it will always give you 0. So if you differentiate 12, it will give you 0. Anytime you are differentiating ordinary number, it will give you 0. Differentiate 50, 0. Differentiate 1000, 0. Differentiate 5 million, 0. Differentiate 2, 0. Differentiate 1, 0. Once you are differentiating a constant, it will give you 0. But once you are differentiating a number and a letter, it will give you that number. Then once you are differentiating a letter, it will give you 1. Don't forget, write it down. Okay? Having said that, the next thing we are going to look at is, so I've said differentiate. So from here, you have letter u and x, so you look for du dx. So if you differentiate x, it will give you 1. If you differentiate 5, it will give you 0. So there's no need for you to write that. Then you come here again. You know, here you have letter y and u. So you will look for your dy du. Dy du. Now if you differentiate u raised to power 6, don't forget you will bring down the 6 and then minus 1. So it will be 6u raised to power 5. Don't forget our rule 1. So you bring down the 6 and minus 1. So it will give you 6u raised to power 5. Then, now don't forget that for composite function, your dy dx is always dy du times du dx. That's the rule. Dy du times du dx. So now, our dy dx is going to be dy du. What's our dy du? 6u squared raised to power 5 times du dx. What's our du dx? 1. You see that? So I will now multiply it. So dy dx will now be equal to 1 times 6. That was 6u raised to power 5. So I will now say dy dx is equal to 6. So instead of writing this u, I will now say what's the original value of u from the beginning. The original value of u from the beginning is x plus 5. So instead of writing u, I will bring it here, x plus 5, then raised to power this 5. That's my final answer. You see that? Now if you are not too clear, play this video again and then you will get it. I am going to do like one more example for you to be clear. So let's assume that you have 4x minus 3 raised to power 9, and then you are asked to differentiate. Look at this. Given y is equal to 4x minus 3 raised to power 9, find the derivative. Now, the moment I have a bracket and a power, I already know it is composite function. So the rule I will use is dy dx equals dy du times du dx. So the first thing I will do, first step, is to say let u be equal to whatever you have in the bracket, 4x minus 3. That's the first step. Then rewrite the question. Y equals u raised to power 9. So that is, I'll write y is equal to, then instead of writing this, because I've replaced it with letter u, I'll write u raised to power 9. You see that? Here, I have letter u and x. So I will find du dx. So I want to differentiate. So if I differentiate 4x, what would that give me? 4. Don't forget I told you that. If you differentiate minus 3, that will give you 0. So you don't need to write that. Then here I have letter y and u. So what I will look for is dy du. So I'll bring down the 9 and minus 1. So I'm going to have 9u raised to power 8. So now following my rule, dy dx equals dy du times du dx. So my dy dx is going to be, what's my dy du from here? 9u raised to power 8 times du dx. My du dx is 4. So from here now, my dy dx is now going to be 4 times 9, 36. So I'm going to have 36 u raised to power 8. You see that? 4 times 9 is 36. U raised to power 8. You will still put it there. So my dy dx, final answer, will now be 36. Then what's the original value of u from the beginning? The original value of u from the beginning is 4x minus 3. So I'll bring it 4x minus 3 raised to power 8. You see that? So that's my final answer. 36, 4x minus 3 raised to power 8. That's your final answer. You see that? Okay. So let me do one more example, then I move away from composite function. Now, let's assume that you have a question like this, given that y equals 3x squared minus 5 raised to power 7, and they say find the derivative. Look at this, find the derivative. So what are you going to do? Solution. So I can say, okay, so let u be equal to 3x squared minus 5. Let u be equal to whatever that is in the bracket. That's the first step. Then the second step, you will rewrite the question. Y equals u raised to power 7. You see that? Because I've replaced this with letter u, so I say u raised to power 7. Now in this first place, I have letter u and x. So I'll look for du dx. Now if I differentiate 3x squared, I'm going to have 6x. Then if I differentiate 5, I'm going to have 0. So you leave that. Then from here, I have letter y and u. Let me find dy du. Now if you differentiate u raised to power 7, that will give you 7u raised to power 6. 7u raised to power 6. So you see that? So I will now use the rule dy dx is equal to dy du times du dx. So here now, say my dy dx is now equal to, what's my dy du? My dy du is 7u raised to power 6 times, now if I differentiate times du dx, what's du dx? 6x. You see that? So my dy dx will now be equal to 6x times 7. That's 42x. Then u raised to power 6. This u raised to power 6, you still put it there. So my final answer will be 42x. What's the original value of u from the beginning? The original value of u from the beginning is 3x squared minus 5. So I'll bring it 3x squared minus 5. Then this 6 on top raised to power 6. That's your what? Final answer. So when you see a bracket and a power, this is the rule to use. It's a composite function or function of function. So my next class, I'm going to be looking at the product rule and the quotient rule.